Thank you all, and welcome to the second annual, I think, Mary, we'll probably do this every year, plenary session on Tuesday. I don't know how many folks were here last year for the Tuesday plenary? One? Two? I'm sure there was more than that. Well, last year, if you recall, we invited a number of thought leaders from outside of our industry to come and talk about kind of the 4 precepts of clean water moving forward: communication, climate, innovation, and investment. Thank you. And we're building off of that this year. We have practitioners this year from across the region. We're really excited to have these folks on stage. Stephen Sanders from WEF is here to help facilitate the conversation. And I'd like to acknowledge Emily Cole-Prescott, Mary Barry, and Mike Murphy from the Innovation Council for all their support in helping to pull this together. It takes a lot of work to make these things happen, and we hope you enjoy it. On your tables, you will find today's panelists and the facilitator and a little bio, so then these guys don't have to drone on about their extensive accomplishments over the years. And then on the backside, you'll see that there's our innovators from the Innovation Council, and those folks will be talking a little bit later with the practitioners about solving our future opportunities and challenges. So I think with that, unless there's any other words from this front table, I'll turn it over to you.
Good morning. No. I drove through a snowstorm in the Berkshires to get here. You can't give me a limp handshake right now. Good morning. Good morning. There we go. That's the kind of energy we need to have this morning. I'm looking forward to this. I was asked about being a part of it, and I felt privileged to be a part of this because I think a lot of times we talk about challenges from a couple different perspectives. And I see this, my day job is I teach operators over at Morrisville State College in New York. And I see people face challenges differently. A couple different mindsets that stand out to me. One is we have a challenge and we learn to just cope with the challenge. What is my coping mechanism for the challenge? And sometimes that's not a bad thing, but at the same time, we just wait for things to be better. You know what, if I just get through this year, if I just get through next year, if I just get through this, I get through this, things will get better. And the other part of that coping mechanism that I think is good is that we need to realize that it's never going to get easier. We have to learn to do hard better. And that's something that we have to do. We have to learn how to do hard better. The other mechanism that I see that some people go into when it comes to facing challenges, and this is the really interesting one that makes me really excited, is I like this saying. It says that when you're green, you grow, and when you're ripe, you rot. So when you're green, you think about that plant that has those new shoots that are green. It's growing. We always see opportunity in challenge. Versus we see a challenge, we just throw our hands up in the air. And I see students like that all the time. But I see other ones who like, I can grow. Here's an opportunity to make things better, and I'm not going to sit back and wait for things to get better. And I like that mindset. So I was super excited with this panel, and we have the innovators and all that because we're going to be green and growing. And I really do appreciate that. So I'm going to introduce our panelists and have them explain a little bit about the challenges that they faced and also the opportunity that lays within the challenge. All right, so we're going to start with Tom Sgroi. That was my first challenge, is saying his name correctly. Executive Director from Greater Augusta. Tell us a little bit, I'm sorry, I got that wrong. Director of Engineering of New Haven. Tell us a little bit about your challenges and perhaps what opportunities are out there.
Thank you very much for being on this panel. I was honored to be actually asked and surprised, quite frankly, because sometimes you go through your career and you don't realize how much experience you've gained. I've been with the authority since 2005, since we regionalized. I'm the engineering director there. One of the recent things, and this is a very basic thing I wanted to talk about to kind of kick this off, is the communication. Communication in the day and age where we all have supercomputers in our hands has become more and more difficult with the community. And have a small example of that, but by show of hands, I'm going to give you my opinion on why I think it's going this way. By show of hands, how many had a grandfather or great-grandfather working with their hands in any kind of related infrastructure, a blue-collar job, if you will, by show of hands? It's a lot, right? All right, today, anyone in your household, are they considered blue-collar, or are they working with their hands, building anything in infrastructure? By show of hands, how many? Yeah, there's like 4 or 5. I think as we went from 1900 all the way through probably 50s, 60s, 70s, we're building this country. You know, we're building infrastructure. You know, my grandfather worked at Fafner Bearing. My dad worked at Southern New England Telephone. He was up on the poles. Everyone in the family had something connected to infrastructure. And I think we've lost that. And it's creating a problem with communicating. We're working on we present our long-term control plan update every 5 years. I just recently did a presentation on that. We sent out public notices, Spanish, English, all over the New Haven papers. We had 6 people show up. Mm-hmm. So basically, I spoke to a camera right there and gave an update of our program. In that same time frame, Luigi DeMonico's here. He's in the back there. Mario Riccosi, my project engineers. We have a sewer separation project in downtown New Haven, and we had to take a corner of a park just for a laydown area. All of a sudden, we got word from the mayor's office that we needed to have a meeting on this. It was become a big deal. So I said, "Yeah, all right, I'll go down there and talk to the residents." And how many people you think showed up to taking a corner of a dog park? 35 people showed up to a very small area. And, it was interesting because I had to introduce myself, say who I was. I could tell who everybody was in the audience because they were all holding Starbucks cups and they all had their name on it. So it was actually an advantage for me. I could actually talk to them. But I started off by saying I own 2 dogs too, but really I raised, I said, by show of hands, anybody know what sewer separation is? Do you know what CSOs are? And really nobody in the audience. And these are not uneducated people. These aren't people that are disadvantaged. These are not immigrants. These are not people that maybe don't have a lot. These are people with master's degrees. These are Yalees. And after I went through the whole song and dance, how important it is for the environment, how important this project is to renewing our infrastructure, they're like, yeah, okay, but how come, what's going to happen to my dog, So these are the things that I think we need to do better. I don't have an answer for this. I really don't. And I think it's compounded by the fact that WEF and NEWEA, all with the right intentions, and our politicians talking about microconstituents and PFAS, all super collegiate, high-level things. We're forgetting about the basic things that keep us, keep our feet dry, keep the sewers flowing, allows you to flush the toilet, take a shower. Those are the most important ingredients, and if we split the baby up into lots of pieces, it's very difficult to fund and afford. I think we have tremendous opportunities to do that. Actually, I was just speaking to somebody before as we walked in on how some of this technology can show the progress of a project with GIS and making presentations like that to the public. Obviously, the more website-type applications could be, to help people understand. But I think we need to go back to the basics. So I probably spoke too long. But
nope, you're right on.
That's good.
We'll come back around to some more communications things. I think that's really important that we need to really spend some time on. Next, I want to introduce to you Gretchen Young. She is the Deputy Director of Public Works from Rochester, New Hampshire, not New York.
Yes, Rochester, New Hampshire, yeah, thank you. I am also very honored to be here. I'm the Deputy Director of Public Works. I've been working in Public Works for about 15 years now, and so we really are the practitioners, kind of boots on the ground, making things happen. So I'm going to talk about environmental compliance. It's very important, it's absolutely essential, but it's also very expensive, and it's very resource intensive for our communities that are trying to meet the environmental compliance. There's the primary costs, which is the capital improvements and the operations that we need to do to get to that. There's also the ancillary costs, which are the staff time, the amount of staff resources that just goes into paperwork associated with environmental compliance is really, it's unbelievable. Public education that's associated with it. Now, we talk about educating the public like what Tom was talking about, but also we have, every 2 years, we have a new city council or new town administrators. So we are constantly trying to educate the decision makers on what this environmental compliance is, why it's important, why it needs funding, why we need to support it. And then the other costs that really do nothing to actually improve the environment are the consultant time, the engineering time, the scientist's time, and also, unfortunately, or fortunately for some, but the legal amount of lawyers and things like that that we need to bring into it. In New Hampshire, we have a lot of permits, but basically we have 3 main permits for environmental compliance that we need to worry about in Public Works. It's the MS4 permit, which is your stormwater regulated. New Hampshire is not a delegated state, so we're regulated directly with EPA. We have our individual wastewater treatment facility permits. So that's what each wastewater facility is discharging. Where I am in New Hampshire, or in Rochester, we have to worry a lot about nutrients like phosphorus. And then what we've been able to do, and this is after years and years of these soft costs or these ancillary costs of legals and scientists, we've managed to work with EPA and the stakeholders to develop, and now we are within our 4th year of what's called the Total Nitrogen General Permit. And that is, as I understand it, really unprecedented way of managing nutrient control. So the Great Bay is having issues. Eelgrass is deteriorating. There are known problems in there. It is basically, the EPA believes, and science kind of backs up, that there's nitrogen levels are contributing to this. The communities have said, rather than focusing all of our energy at the wastewater treatment facilities, these point sources, let's do non-point sources, which is a great, great way of tackling an issue and really goes after the much bigger causes of the nutrient being brought into the Great Bay. However, it's much, much, much more difficult to regulate. So with this general permit, right now, we have basically 2 different ways of being measured. We've got very specific measurements at the wastewater treatment facility, which is easy to do. You just take your, you take your samples, you run your analysis, you know exactly what you're discharging, you can follow that. But then the non-point source is much, much, much more difficult. So this has, its challenges, but it's a great opportunity. And the communities, there's 12 communities that are permitted with this general permit, and as I said, we're in year 4, so we really don't know what is coming. But we've band together, which is not New Hampshire. It's not intuitive to New Hampshireites to band together. And I've said this at a number of conferences, but that live free or die mentality is real. Mm-hmm. It's not let's work together, let's collaborate, let's pool resources. So we have right now 8 of those 12 communities have joined together in what's called the Municipal Alliance for Adaptive Management. And the way the permit's written is called adaptive management. So we actually have a permit that talks about trying something, learning from your mistakes, reevaluating, retrying. But there's a lot of trust that goes into that too. So the communities have to step up and do something. It basically says, try or jump, but it doesn't say how high. It doesn't say exactly what you need to do. So we have to absolutely give it our best, grow, kind of face this head on in order to do the best that we can. And we have to trust that the regulators and stakeholders are going to recognize those contributions that the municipalities are doing and allow that adaptive management to happen, because it's harder for them too. It's hard. They can't just say you need to meet this, this waste load allocation, you need to meet this. If you don't, we can come after you. It's a lot of trust in that. So like I said, lots of opportunity, lots of challenges. Other challenges is because it is so vague, it's really hard to plan for the future, like large capital improvements, like upgrades to your wastewater treatment facility. That's something that the city of Rochester has to do. We're quickly growing, taking, I think, a lot of transplants from the Boston area. And so we are going to need to upgrade our wastewater treatment facility. So what do? Do we think that this adaptive management, which we believe is working and is the best way of doing it, do we think the regulators, the stakeholders are going to agree with us? Or do we plan to put this very, very expensive infrastructure in? So while we believe that we're making the right progress, it's also very difficult for us to know what's coming next. That is kind of the crux of what I've been talking about. So there's a lot more to it, but
Thank you, Gretchen. So we have also too, I want to introduce you to Janine Burke-Wells. She's the Executive Director of Northeast Biosolids and Residual Association. What are some of the things that you're seeing right now?
So some of the challenges I've seen, certainly, I mean, I served as a regulator for a little while and an operator, so I have a different perspective, I think, maybe. But certainly on the climate change, I was the head of a treatment facility that got completely wiped out, including 6 pumping stations in 2010. The 10 years I worked in wastewater prior to that, we had 1 major flood, took out a pump station, wasn't a federally declared disaster. Like the first 5 years of my next gig, 4 federally declared disasters. So just experiential data that things are changing. And that's when I really started to learn about this energy-water nexus and what can we do to reduce greenhouse gas emissions. And so that's certainly a challenge. The regulations are a challenge. I think you touched on it a little bit. We need a new paradigm, I think, for regulation. We did great for 50 years with the point sources, but now we have other problems we have to deal with, and adaptive management is a great way. I don't think that's currently the paradigm. And it is hard. I agree. It's non-point source regulation is hard, but the hard's what makes it great. If you ask me, let's just grab that challenge. I think another challenge is contaminants of emerging concern, PFAS, how we talk about those, what we do about those. Another big challenge, and Tom kind of alluded to it, but people don't know what we do, and they have negative perceptions of what we do. So we're starting with that, and it makes it very difficult. So the communications are definitely a challenge, I find. And I feel like water resource recovery facilities are being asked to do a lot, all right? They're monitoring for COVID now. They're reducing their greenhouse gases. And they need support. They need support for that. So on the other hand, as an opportunity, I think in the future, I see water resource recovery facilities becoming the community anchors, right? Wouldn't that be cool? Generating water for agricultural use, nutrients, power, energy, all of that. I think that would be a terrific opportunity for us as a profession. I think there's a lot of new sources of money out there. I learned this when the flood happened. EPA, SRF, that was where we got our funding for stuff. And then I had Department of Economic Development, Department of Energy, CDBG funding, like all this funding sources I never even thought about. And now a lot of Department of Energy funding's being focused on resource recovery facilities. So there's opportunities in that. And there's also opportunities in new partnerships and collaborations. You talked about collaborations. We have to all work together on these problems. So we need to start working with farmers and agricultural entities, energy providers, other kinds of utilities. I want to just give a shout out for one particular collaboration that's ongoing right now, the BioHub that NEWEA developed. Is bringing regulators and regulated and technology developers and everybody together in this kind of a central way to look at the problem of PFAS and biosolids is what I'm dealing with. So again, the biggest opportunities I see are in maybe changing the way we regulate things so we can get there faster through innovation. I think it stifles innovation right now.
Gotcha. Good. Next on our panel, I'd like to introduce you to John Livsey. He is a town engineer of Lexington, Mass. Tell us about what you're seeing.
Thank you very much. For those that aren't familiar with Lexington, Mass., it's a fairly affluent community. It's about 15 miles north of here, and it's where the Revolutionary War started. The shot heard around the world, that was Lexington, although Concord will claim it, but it was in Lexington. Gretchen brought up non-point discharge, and it reminded me of 30 some odd years ago when I was in grad school. Quick little story. I had an assignment in a geology class for doing a report on non-point source discharge. I had no idea what it was. Couldn't find anything in the library on it. But there was a technologically advanced student that was a friend of mine who, hey, come on over here. There's this new thing out there called the internet. And we searched. It wasn't called Google at the time. I don't remember what it was called. We searched for articles on non-point source discharge. I think we maybe had 8 or 10 articles. You'd probably get a few million now. So I was glad to be done that report and never have to deal with non-point source discharge again in my life, which 30 years later, it's a major focus of my job. So for our community, we have numerous challenges, but in the stormwater world, our number one biggest challenge in stormwater quality is phosphorus removal. We have a phosphorus TMDL in the Charles River watershed, which is part of our community, as well as the Mystic River watershed, which is also part of our community. Our community is the headwaters for 3 different watersheds, so 2 of them have the phosphorus TMDL. Very big challenge. We have to remove approximately 700 pounds of phosphorus from our system, which when you first think of 700 pounds, I'm like, well, I could carry that. It's about 10 trips to the house from the driveway. Not a big deal. And then you start calculating what it takes to remove that amount of phosphorus and the amount of infrastructure you need, the amount of land you need, when most of our work has to be done in the right-of-ways or on town properties, and it starts becoming a little bit overwhelming. So, but as an engineer, what we do is we get problems and we look for solutions, we solve them. So on top of that, stormwater quantity is a huge issue. And this year in particular, it seemed like it rained every other day, and the storms were enormous. And we had incredible flooding all over town. So we have, aging infrastructure that was designed 30, 40, 50, 60 years ago that's not designed to carry these kinds of storms. And even if we had, all the money in the world, we just can't increase the size of our pipes because it needs somewhere to go. So, so that's a challenge as well. So how do we solve both of those problems? We have a community that does understand climate change, does understand these challenges, is a progressive community. So when you talk about improving stormwater quality, they don't push you away. But when you start looking for funding, and their house and their basement's flooded, and their road they live on is closed because it's flooded, that's where they want the money to be spent. It's hard to communicate to them the importance of the stormwater quality issues. So, what we're trying to do is find ways that we can solve both of these problems in similar footprints. Can we, if we're looking for funding, if we can build something that helps solve the flooding problem, but can also solve the nutrient problem or help solve the nutrient problem, it's a much better sell. It's better for the environment, it's better for the residents, and we're much more likely to get the funding for that. I do see the phosphorus challenge is the most difficult challenge I've seen in my 30-year career, and I've had a number of challenges over that career. Dealt with a landslide in the community, failing dams in the community. So, but this one, I feel like we really need to find some innovations to make our systems to remove phosphorus much more efficient, able to do it in smaller footprints. I'm assuming people that have to deal with nitrogen are seeing the same concerns. We can't, when we have several hundreds of outfalls, I can't have a treatment plant at every outfall. So it's some of the great technologies you can use at treatment plants. We'd like to see somehow for that to get involved into stormwater. So I'd love to hear if some of the innovators have ideas on what to do for that. And one other thing that would help that we plan on using to help sell these things is just maintenance. Phosphorus comes from leaves, comes from sediment, things like that. If we want money to clean the catch basins more and sweep the roads more for removing phosphorus, the residents don't really care about that, but if their roads are getting cleaned more, so they have cleaner roads, that we can sell. So we need to be able to tell that story, communicate that effectively, and get the community as well as regulators on board with those types of solutions.
Sure, thank you.
Thank
And then also, too, we have Brian Tarbuck. He's the Executive Director of Greater Augusta Drinking Water and Clean Water. What are some of the things that you have noticed?
Yeah, my name's Brian. I'm from Maine. Show of hands, Maine folks. Anybody repping? All right. If you haven't been to Maine, it's that way.
Vacation land.
Augusta, you go to Portsmouth, which is in New Hampshire, and you go 100 miles north, and that's Augusta, Maine. That's where our state capital is. It's lovely this time of year. You should go visit. That's called Central Maine. If you keep going another 300 miles, you reach the end of Maine and get into Canada. So why Central Maine is only a quarter of the way into the state, I'll never know. But that's where we're at. Our utility is a utility district. It's not a municipal district. We're separate from the municipal communities that we serve. We provide drinking water services from wells. We have a PFAS issue. We have CSOs, but we're not an MS4 community. And we run the wastewater plant, our sewer collection system for our local communities, and also provide more or less wholesale wastewater collection for outside communities. The challenges that we face are communications is the number one. We invest quite a lot of money into that. We have a great website, gaud.ws. You should look at it now and often, and like us on Facebook if people still use Facebook. I think it's old people, which gets to the point of, I hadn't thought of myself as really old until the green thing, and then what was the other one? You're ripe. I think I'm more on the ripe than green anymore.
Stay green, stay green.
But once you said that, my whole thing went sideways. So communications clearly is the biggest problem. I think if people knew what we did, why we did it, and why our rates are getting ever higher, then they'd be more sympathetic to what we're doing. Our river's gone from Class C, which wasn't very good, to Class B, which is very good. We have a lot of fish returning. That's a positive thing. We've knocked down CSOs from somewhere around 19 to I think we're well under 10 now, but still the second most CSOs in Maine, only second to Portland. So even though we're a small community, a lot of those issues, and that's really driven us on the wastewater side for a long time. On the regulatory front, we're very different from some of my peers up here where we're not regulated directly by EPA. We have our own state regulatory agencies. So our regulatory environment's very different. All those regulators are in Augusta, which is where our office is. So we really can't get away with anything because they'll tell us problems on their way to work. Like, did you know you had a water main break? I'm like, I didn't, but thank you. Thank you very much. But on the flip side, they're also coaches of the local basketball team. So we have those good relationships, which is important. And then finally, the financial piece is very important. Our community isn't very big. A lot of folks work for the state. They don't make a ton of money, and they're sensitive to rate impacts. So we're always trying to navigate that. But I think communications really solves a bunch of those other problems. So for me, looking back holistically, you think, well, how can we better communicate our needs with our ratepayers? And one of them is geographic information system. For me, it's the most powerful tool that we have as a utility to show somebody where they live, where their pipes are, and then instantly there's a half-hour conversation about, I didn't know that, I didn't know that, I didn't know that, even though we send them newsletters and we have a really good website, which you guys are checking out right now. So I think that piece of technology in that, if people know when they have a combined sewer overflow, that's something I need to know anyway. Why wouldn't I share it? Maybe it's alarmist, but maybe it'll help somebody care a little bit more. So when they see their bill, they understand why they're paying those higher fees. So As far as technology goes down the road, I think it's, of course, all going to be geographic information systems or something along those lines, so we can better represent what we do and what our concerns are in our utility in a visual way that we can track over time. So when I finally do rot, which could be any day now, apparently, it's going fast, that whatever limited information I knew is at least recorded in some digital media that can be shared with our successors. And I think there's some innovators here today that have some technologies that might help augment that. But that's it from Augusta. Please come up and visit. It's great. Thank you. Back to you.
Hey,
Where are you on the scale, by the way? Are you on the rot or still
I
green?
try to stay green.
Okay.
But then I grew a beard and it was all gray, so I might be closer to rot. So I just want to flush out a couple more things that I heard here. One of the big things that I heard was communications. And we'll have a little discussion amongst ourselves before we get the innovators out, is, what has changed? For a while, we accepted a certain standard with regards to communication, and now all of a sudden we're looking for something different. So what has changed? What's driving the need for more communications versus, and I do some of this work too, versus if they don't know about us, we're doing our job mentality? What have you seen that's like, all right, why now? Is it regs that are pushing it? Why now do we need to communicate differently?
I'll start that off if you want. I saw a big change. COVID changed a lot of things. And I think it continues to a certain extent, especially in the cities. A lot of people working from home. I think when you're working from home, you're more aware of what's going around your home when you're not at work, obviously. So I think you have a lot more eyes on what you're doing. The project I talked about, we actually have 2 projects going on in downtown New Haven. We've never had so much attention from the aldermen and the public in general. And I say we do an okay job of getting the word out. I think we could do a better job, but I think everybody can always do a better job, right? We have limited resources to do this stuff, and technology is helpful. I think COVID had a major shift in the amount of people that are noticing what's going on, but yet again, they don't really understand what's going on. So it's conveying that message.
Yeah, in our industry, I mean, that has always kind of been that mentality, but COVID did reset everybody, and it gave us time to think. And it's like, all right, and here's a term that I want to get rid of: public relations. Because we make a line between us and the public. It's community relations. We're part of the community as well. Any other thoughts with regards to, go ahead, Gretchen.
Oh, yeah, and I don't want to speculate on exactly why, but I will say an experience that I had recently, actually working for another community in Dover, New Hampshire. We spent years with communication about what a stormwater utility could look like. It was scientific based. It had pretty pictures, it had websites, it had information, it had all of these things. They were trying to reach everybody. And within the 11th hour, and I had actually moved on at this point, but within really like 2 days of the final vote, some sort of hysterical, more alarmist opposition was able to drum up so much more support, reach so many more people, that ultimately it went to the city council, and they weren't able to support it because seemingly all of the information had been just this negative. And so kind of trying to figure out a way to communicate in a way that isn't, I don't want to be hysterical and alarmist, but I do want to reach people. So that's something I'm grappling with right now, big time.
Go ahead,
I just
Janine.
think the way people get their information has changed dramatically, and we need to change with that method. I don't know what the answer is, but nobody reads a newspaper anymore. I mean, our newsletters, those, and yeah, you can go to a public meeting and somebody's got Google on their phone and they're the expert testifying to the city council. So I don't know I don't know what the answer is to that.
So, and so I think what you're saying, a lot of that is meet people where they are.
Yeah.
Right? They're not in front of a newspaper anymore.
No.
So there are other things that we can do to actually reach them. Let them know, and then they'll be the first to tell you that, you know what, you work for me. Well, great. my issues are actually your issues. Let me tell you about your issues. Good. So I don't want to go any further without giving time to our innovators. So I am going to bring up Beacon Energy Solutions. We have a representative from them. Come on out. We have a mic set up over here. And introduce yourself. Tell us about your product/solution, your target audience, what stage you are in development. Where do you see where this thing could actually fit into the water community?
Thank you very much. It's an honor and a privilege to be here. My name is Jeff Hammer, and I'm with Beacon Energy Solutions out of Nashua, New Hampshire. Some of you folks might remember me. I was on the NEWEA Energy, I should say Innovation Committee for about 3 years with UREG Energy from Wastewater out of Zurich, Switzerland. And I see an awful lot of familiar faces here in the audience today from that committee. What Beacon Energy is doing right now, and a little bit of background on the company, is we are, I believe, the largest distributor of solar solutions in the state of New Hampshire, and one of the larger energy solutions companies in New England. We're working right now closely with a company by the name of Skywinds out of Hanover, Germany. And Skywinds has developed a product that's very innovative, which is why I believe we were invited to be in the Innovation Pavilion today. It's a wind turbine that's less than 20 pounds, so most people could carry it under their arms. It's less than $3,000. And it generates, depending on where you are, the average turbine is about 1,000 kWh a year. When you get closer to the water, it's about 2,000 kWh per year. One of the recent partnerships with Skywinds did is with Kaufland in Germany, because they are a German-based company. Kaufland is the Home Depot of Europe and the Lowe's of Europe, and they've sold tens of thousands of these units across Europe. So it's something that is very common or very popular in Europe, less popular here in the United States. We're hoping to change that. I don't know if any of you folks use LinkedIn a lot, but I sort of live and die on LinkedIn. My daughter works for LinkedIn. She's worked for them for about 10 years. And if you notice, the governor's office in Maine went on a fact-finding mission. I would have loved to have joined them for about 10 to 14 days in Denmark. And they were investigating wind solutions for the state of Maine. So it seems like they're really pushing wind, or at least it gives the appearance that they might be pushing wind in Maine. We're meeting with the governor's office of Maine in March, and we're looking forward to talking more about them with wind and see where this goes. We have some meetings with the state of New Hampshire tomorrow, and we're going to see where this goes there too. So it's kind of new here in New England. I think it has a great deal of applicability in a wide space that may include the water industry. It's easy to install. The Germans, who are quite strong and innovative themselves, they do this. They install it themselves. They just they buy one for maybe their home, for example, and they just take it home and they put it up. It's that easy. So it can be self-installed. Although for larger installations, I would suggest a more of an expert, particularly with the electric side of it and with the carpentry side of the installation. So that's what we're doing. I want to keep it less than 5 minutes. And if anybody has any questions, I would be delighted to answer them. And once again, it's always a privilege and honor to be here. I'd like to thank NEWEA very much, and thank you very much for your time. Appreciate it.
So, Jeff, don't go anywhere.
Okay, I'm sorry.
We're going to throw it to our panel and see if they have some questions for you. Maybe I can get the pot stirring a little bit here. How do you see this filling a gap? Are there certain perspectives that perhaps need to be addressed? I mean, how can we, again, this is innovation, so it's like, I have it on my wall. It's what you learn after you know it all that counts. So the collective ideas of all you folks. What do you think about what Jeffrey brought to the table?
I mean, I think it's great, taking advantage of the wind. There's a lot more of it lately, it seems like. But is that a practical solution? Could a wastewater treatment facility install like a bank of these to reduce their energy usage and have more renewable?
Yeah, for those people who are very quick with math calculations, you'll figure out, okay, 1,000, let's say on the optimistic side, 2,000 kWh a year, that's not too much. I mean, that's probably a very modest Cape Cod size home. So is this applicable to the wastewater industry? Assuming that all wastewater treatment plants or facilities have offices, which I believe most of them do, and you say, okay, well, what we want to do is, we want to practice what we preach. We want to become greener. We want to install, let's say 4 of these for $10,000, and there's going to be, I shouldn't say there's going to be, I would expect that there will be subsidies, in different programs, whether it's through National Grid, through Eversource, something like that. I mean, you're going to get subsidies. It's a modest solution, a very modest solution towards a bigger problem. I will say one thing, though. I want to go back to URG for a second, because I continue to have a very friendly relationship with them. Is, we had, and still have, a great product. They're the largest energy from wastewater provider in the world. And, we were here for 3 years before we had to shut operations down. And what they were able to do, again, you're installing energy from wastewater, providing energy at maybe 4 or 5 cents per kWh. And there was a couple wastewater treatment facilities in Boston that in 3 years couldn't make a decision on whether or not they would let us put these things, these heat exchangers in their lines. They said it's a 5-year decision. It's not a 3-year decision. So I know that we love to talk about, reducing carbon, reducing emissions, reducing energy spend. God, we love to talk about it. But when it comes to action, it's kind of like, I believe that there's an expression, I don't know if it's from the Marines or something to that effect, where it's like less talk, more action. And it just seems like right now, when you talk about, energy efficiency, you talk about, about global warming, it's talk, 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 talk. Where's the action? Where's the action? We had 9 or 10 projects ready to go in Boston. They're still there. They're still ready to go. They're still waiting. And you're just waiting. You can't wait forever. You think you'd rather receive a quick no than a forever maybe, or at least I would. This is, and once again, that it's not maybe the ultimate solution, but these systems that I mentioned, they can be installed at any wastewater treatment plant anywhere in the world, and they are. They're currently all over the world. So I diverted a little bit from wind to wastewater. I apologize. I'll come back to wind, but it's sometimes, this is my 43rd year in the industry. It's just a little frustrating whenever you hear, so much passion or perceived passion about energy efficiency, and it's like, where's the action? Where is the action?
So you will be around a little bit later?
I will be around for as long as you want me to be.
All right, yes. So if you want to have a chance to talk with Jeff from Beacon Energy, by all means, thank you very much.
Thank you.
Appreciate it. We also have a representative from Dewberry. Are they in the building? There he is. Tell us your name, your product, solution, where you're from.
My name is Lou Memolette, and I'm with Dewberry. I'm also here today with Michael Hanley from our team. We're here to kind of showcase an idea that we had an idea, and we're trying to showcase sort of the solution to solve a problem driven by the need for doing a better job to execute a certain task that was needed by a community and one of our clients. Quick fun fact, John and I actually went to college together.
It is a small world.
He was actually right behind me, and I looked you up on LinkedIn or whatever, and you were in the group right behind me in undergrad and in grad school, so go Riverhawks. All right.
So you were pre-internet. I was internet.
I remember when AutoCAD was in DOS.
Same.
And we were not allowed to touch it.
Go Riverhawks.
Exactly. Just real quick, Dewberry is a civil engineering firm. We're a national company, and we're a big sponsor of this conference. We are a traditional AEC firm, but the younger people in our office and in our company are definitely leaning more towards some of the technologies, and GIS and asset management really are kind of going hand in hand together. What we created basically was a GIS-based application to manage information and the process of cross-connection control and backflow device testing. So I guess just quick show of hands, Does anybody here work for a public utility water system? Okay. Does anybody here consult to public utilities or water systems? Okay. So in general, if you're in the water industry, you understand cross-connection control is a big deal, and it's definitely problematic despite the process and despite the regulations. There's a lot of local control that needs to be exercised, and if things aren't being monitored and managed and inspected and tested on a regular basis, then really it's a lot of talk and not a lot of real peace of mind and protection. My hats go off to the people that actually do the testing and go out and get trained, because they're really the front line to make sure that this is happening. All we did was create a GIS-based application to make the paperwork go away and to kind of improve the experience of trying to manage the data. We've done this in many instances for sort of many different applications, but this is sort of one in particular where we had a client that was looking to sort of automate a process, and we just utilized kind of standard tools to do the same thing. There's a lot more that goes into it, and what I would invite is anybody who would like a little bit more detail and kind of behind the scenes dive on how that works and how it can be done for your community or any community. It would be good to just kind of come by our, kind of our table, and we could kind of walk you through the demo of how it actually works. But I'm happy to take questions and also pass it on to my colleague if there's technical questions related to it or crossover from other issues that you guys are talking about.
So I'll just say, let's throw it out to the panel real quick here. How do you see this fitting in? Do you have questions about perspectives that might be being missed? Or I know Brian got a question there. We let him go.
Yeah, thanks. This is something we dove into this summer a lot, and I'm glad to be here because the intern that we hired to do it is going through tough. She's almost done with her master's. She's going to work for you guys at Dewberry, and she's excellent at surveying.
This is Madeline Dwyer you're talking about?
That's it, yeah.
Excellent.
She's outstanding, and she loves the forums. And I told her I was going to tell you in a big public forum that that's her favorite thing in the world to do. So make sure she does a lot of that, and she'll thank me forever, I'm sure.
We will be all over that. Thank you.
She's excellent.
Go ahead.
Just in the municipal world that we live in, there's constantly more regulations, more things we have to comply with, more work to do, but not more employees to do it. So finding efficient ways to do it, efficient ways to manage the data is critical in order to get more work done with the same amount of bodies. Data management can envelop your entire job if you don't find efficient ways to do it. So I see this as something that can be very helpful for communities.
I agree. I'd like to be on this panel next year, and I'd like you to put about 3 hours together, and you could ask me a couple of those questions because I would launch into a lot.
And it's funny you said
it's understaffed, it's underfunded. Can I just answer one of the quick questions? The thing about the public, the public's important. They pay the bills. There are the people who generally want to know and are helpful and actually say thank you and good job, and they appreciate what you do. There's about 5% of those folks. And then there's 5% that will just complain about anything, who know nothing. And then there's the 90% in the middle who kind of don't care, and they don't, and which is kind of unfortunate because 90%, that's 90% of the revenue that you generate. So I think there's a real challenge there in communicating the importance of it. And don't forget, you're competing against the T-Mobile bill, the Verizon bill, the Comcast bill, the Netflix thing, all these other things where they put money in, and people freak out if they don't have those things. But they need water and sewer.
Yes. So Lou will be around afterward as well, correct?
Yes.
All right. And it's funny you said we're asking to do more with the same amount of resources. In many cases, we're asking to do more with less resources.
I was trying to be optimistic.
You were. Thank you so much, Lou. We appreciate that. We also have a representative from Opti RTC. Introduce yourself.
All right. Thank you for your time, and thank you for the opportunity to speak here. My name is Alex Bettig. I'm the CTO of OptiRTC, and we're a company based in Boston that really started based on the recognition that stormwater management had to do more with less. We had to understand that we were in a hard place and we needed to do better. And that hard place was this legacy that we had started with, which was always about quantity. It was always about making sure that the sewers were flowing and making sure that there was capacity. But then the goal changed. We realized that quality became important, whether it was nutrients or the effects of the nutrients on the water bodies that are receiving them. We understood that we had to do more with the same resources that we had, and yet in the meantime, the problem had gotten even harder because the collection system had grown as the city had grown around it. And depending on your perspective, the rainfall that we're managing. You know, the design storm never happened, but now the storms are even bigger than they used to be, and the intensity is different than they were anticipated to be. So where are you going to put this water, given the fact that you've built a city or a community with assumptions that cannot be revised? You can't tear up the old town. You can't unearth the pipes and rebuild entirely from scratch. And so what we understood is that we needed to control the timing of the flows across the upstream areas of the watershed, because that's really the only place where you can put the water. And that if you're able to do so, you're able to start taking assets that were originally designed for quantity and start also achieving quality goals with those same assets. And then as you're able to scale up that approach, achieve more and more of those quality goals without ignoring the important quantity problems in the way. So how do we do this? We are a technology provider. We have a solution that integrates sensors in the ground with weather forecasts from the satellites and cloud-based engines for understanding how do you achieve the objectives that are necessary for that community and for each one of those sites. And so we operate the flow controls that are installed on stormwater facilities, and then we can help engineering consultants help design and install those flow controls on facilities. And we make it possible for those facilities to change their behavior every minute of the storm, and then using the data that comes out of those storm events also help the people who are deciding how well is this community functioning decide where do we need to prioritize other changes, maybe reconfigure the way that the system is functioning with software rather than a civil design project, and continually optimize the way that individual sites as well as the entire collection system solves the problems that the community is asking of it. Not just the quantity, not just the quality, but all of it together. And whether that's erosion, you know, something you hear more on the West Coast, just slowing the flows down as much as you can. That mentality of always doing as well as possible every single time it rains and actively controlling it to make it as good as possible is incredibly powerful, not just because it works, but because it creates trust in the information that's coming out of it, because you see every single time that it rains that there has to be some sort of decision. We're either going to do something or not, and how well did it do? And how well would that have done compared to passive, or what the alternatives could have been? And being able to tell those stories on a repeated basis, because it rains 50 to 100 times, 50 to 150 times a year, most places in this country, being able to tell that repeated message of it rained, we made progress, here's the results, it allows for a different conversation with the communities that are experiencing these solutions, because they don't have to always be paying attention. They get the basic cadence. You know, it rained, okay, you held the water, and then you released it slowly, and that was better than not doing it. Great, but if you see that message over and over and over again, it draws people in a different way, and it helps also to be able to engage around this idea of we actually have multiple objectives now. We don't care about just quantity. We do care about quality. We do recognize that the nutrients matter in terms of what we're putting into the receiving systems. And that decision has been consciously chosen because there's a different strategy that's relevant for the largest storms than what works for most of the storms, which are much smaller. And so now we can engage people with a meaningful discussion. It's not just presenting data. It's not just presenting websites. Nobody wants to look at things they don't have to look at. Attention is our most scarce resource. So if you ask people a question that gets them to be to feel like their opinion about, well, we can protect for water quality except if it's going to be a really, really big, and what does really, really big mean? Now there's a voice that's being codified in the way that the system actually operates. It's being able to distill the question into a conversation of priorities and objectives, as opposed to a presentation of science, which I like, don't get me wrong, but I'm not the main person that needs to be sold to here. And I think what we're focused on doing is making sure that every single time it rains, that story of how an improvement was made and how it can achieve multiple objectives, and then across the year, across the whole set of storms, there's been a significant improvement across the objectives that matter. That's really where I think our approach, we call it continuous monitoring and adaptive control, has a role to play in changing the way that communities engage with their stormwater collection systems, because finally we can encode their voice in the way that the system is functioning. And I know there's probably some questions. I can go forever, but please,
all right,
thank you.
so we got some stormwater people here. So by all means, Alex is listening. Go ahead. We're going to start with Tom.
I love what you're saying. In most communities, when development's coming in, whether it be a commercial development, subdivision, the regulations say control your peaks. They don't say when to deliver your peak. They say to control your peak. A higher peak isn't necessarily bad if it hits at the right time. Get one peak out before the next peak comes in. And if I'm understanding what you're saying correctly, this adaptive system will help with that. So someone doesn't mind if the stream is a few feet higher, as long as it's not in their yard and in their basement. If it's a few feet higher for 5 hours versus 2 hours, they're fine with that. If it's several feet higher for 1 minute and gets into the house, they have a problem with it. So this adaptive control can help adjust those peaks so they're not hitting at the same time, causing those major flooding events.
Exactly. Basically, the whole city can take turns sending its peaks downstream so that whatever is receiving it doesn't have to deal with the big event all at once. Yep. And a common way that applies is with a combined sewer overflow system. You've got a sensor downstream in the interceptor sewer that can say, okay, the wastewater treatment plant can't handle anything else now. And by the way, it didn't rain the same across the whole city. Some of the subdivisions have more capacity than others. So maybe the ones that don't need to discharge right away can hold things back longer and let the rest of the system have the capacity that's there. And then kind of another idea that comes up often is first flush. Peak flows are important, but where do the nutrients really come, especially if it's a highway, and it depends on your soil and all sorts of things, but it's the first flush. It's once it's rained, that first 15 minutes, first hour, whatever, depending on your hydraulics, but that's the part of the storm that must be caught. So if we have lakes or wet ponds or features that are always storing water, and we can predictively draw that down to create the capacity to collect that, effectively making all the effluent that you're managing as old as possible. We call that distributed primary treatment inside. We don't market it that way, but your comment about we want the wastewater treatment plant elsewhere, now I'm thinking maybe we should. That's essentially the idea. And it's really that mentality, though, when it comes down to it, is using information as well as possible to make the changes that are necessary during the storm, between storms, and across the larger budgeting cycles that occur as investments are made about how the community changes.
Okay.
And that's what we're up to.
So we'll take one more quick question. We got to get to the rest one. Gretchen, you had a comment or perspective?
Sure. I was going to say, I've been thinking about doing something similar for a long time, but a lot of us work in these really old New England towns, and I'm just curious how well you can do with, I don't know what those pipes are. They're infiltrating, there's volume we don't have mapped. How does that work?
Sure. So, one of the things that we always were focused on is, do you need to map the entire collection system in order to benefit from our approach?
Yeah.
And we kind of early on decided that was not going to work because, frankly, stormwater projects don't always happen all at a community scale. They happen parcel by parcel as funding is available. And we need to fit into that world. And so that's why, if your design plans or code requires certain changes at a site parcel level, we can work with you about what are the objectives of that site and how can we achieve them better. Sometimes that means you actually don't need to build as much storage depending on what you're looking for, which can be a big savings to the developer. But oftentimes it means you can achieve your water quality goals with that parcel that otherwise would have had to compromise. You know, I mean, if you're trying to slow water down, you need a much smaller hole for your outlet structure than if you're trying to get it away as fast as possible. That's for flood protection. So not having to be stuck in that paradigm where you're designing once for a design storm that never happens, and then just having to live with the consequences, but truly being able to have the right size for each event, even at a parcel level, can make an incredible impact. And that's, again, it comes back to the data. The data is basically table stakes. You have to be able to do the data in order to do everything that I'm talking about. But the stories that come out of that, even at a site scale, I mean, our customers win awards for it because people see that this is actually doing something different and better, and it's more consistent with our values than what we would. And maybe that can be the whole community someday. Is the way that conversation usually goes.
So you will be around as well?
As long as you'd like,
Other
yes,
questions.
absolutely.
Yeah, as long as there's other questions. Yeah, we're going to get to some of our other folks here.
Thank you.
We have thank you again, Alex. We have someone from River Otter Renewables, Inc. Introduce yourself and tell us a little bit about solutions, challenges. What are you actually looking to do?
Okay, thank you very much for this opportunity. My name is Hal Walker. I'm a professor at Worcester Polytechnic Institute, and I'm representing River Otter today, River Otter Renewables. And River Otter is a startup company, a pretty early stage startup company that is born out of research that has been going on at WPI for many years on a process called hydrothermal liquefaction. And River Otter has a patented hydrothermal liquefaction, or HTL, process for the recovery of energy, the recovery of nutrients, and the destruction of PFAS in sewage sludge and biosolids. So that's the main technology that River Otter is developing related to this conference. River Otter also looks at other organic waste, like food waste in particular. River Otter Renewables, the technology, there's a number of innovations as part of HTL. In terms of the energy recovery, we have an autocatalytic process that's part of the HTL that results in very high net energy yield. So if you're looking at it does take some energy to go into the process. If you're not familiar with HTL, it's a process where you take an organic waste and you heat it under moderate pressure, and from that, it's like sort of a pressure cooker, I guess, if you've ever used a pressure cooker in a restaurant or a house. It's kind of an analogous idea. So one of the, in terms of recovery of energy, it has very high net energy recovery. So some energy goes into it, but the net energy yield is very high. We're working on ways to upgrade the technology for the recovery of nutrients. And in particular, we're looking at nitrogen, phosphorus, and sulfur. And we're using catalytic processes on the front end to convert organic forms of these nutrients into inorganic forms, which then we have a patented salt precipitation process that will take these nutrients and generate a form that's usable, for example, in agricultural applications. And then the third piece is the destruction of PFAS. So we've got renewable oxidation modification to HTL, which our preliminary data shows very high destruction of PFAS in sewage sludge. And so not only are we destroying the PFAS in the sewage sludge, also the nutrient streams that are coming out of this are also free or very low in PFAS. Okay. So as I mentioned, we're in the early stage. We have partners, a number of partners that we're working with. We have funding from the Department of Energy. We have an SBIR grant through US EPA, and we have some funding from the US Air Force. And we've partnered with Pacific Northwest National Lab, who's a real leader in HTL. And we're initiating some pilot studies with municipalities, a number of municipalities in Massachusetts. So that's kind of where we are. Where we want to go is we want to see, really we're at this conference to listen and learn and hear from municipalities and wastewater treatment plants in terms of how can we take where we are now and really make this a robust solution for a large number of facilities dealing with issues of biosolids and sewage sludge, and trying to think not only about dealing with PFAS, but also the new idea of the circular economy and trying to recover resources from sewage sludge and wastewater in general, and view it as a resource, not as a waste.
Thank you. So Hal, I'm going to forgo the questions to keep us on track here. but it's very easy to see where this could fit into the water sector. I mean, it's pretty obvious. So Hal, again, you're going to hang out and you'll be around. Yeah. Harold or Hal?
Either one.
All right. But thank you very much.
Right.
We appreciate that. I want to make sure I get everyone in here in time before lunch or whatever. We have a representative for Trinex.
Hey folks, thanks for having us here. My name is Varun Srinivasan. I'm representing Trinex today. Trinex is a digital solutions company that aims at delivering digital solutions to the infrastructure sector, specifically the water and wastewater industry. We have a team of software developers, water professionals, water engineers, and data scientists who aim to bring data that is distributed across several different platforms into the hands of the stakeholders. We have three arms, essentially. We have a custom solutions arm that delivers custom digital solutions to the infrastructure sector. We also have a digital consulting arm, which helps with thinking about digital transformation for utilities. And we have a software arm that develops softwares that are aimed at solving common problems that are seen at utilities. I'm going to specifically talk about the software arm today. We have a platform called Watercast, which is kind of our flagship platform that we have developed. That's a digital water platform that aims to bring together data from disparate data silos and data sources. I heard a lot of talk about communication, overflows, water quality, and a lot of the problems associated with this are all driven by data, which is available a lot in our utilities, but not immediately available at the arms of the decision makers to actually be able to communicate at the right time with the right information to the right people. And that's kind of what Watercast aims to deliver. What we try to do is bring all of the data sources together. So if you have SCADA data historians, you have lab data, sampling data, you have GIS information, you have CMMS, work order, cleaning, maintenance information. We bring all of those data pieces together into our platform and then use AI and advanced data analytics to deliver insights based on that data. As a platform, what makes us unique is that we are also not only able to deliver custom solutions to tailor solutions to the utilities' needs, we also have three core applications that we have developed. One is called Watercast Sewer, which is aimed at collection systems, sewer networks, aiming to help operate collection systems more efficiently. We also have a water quality product, which is meant for treatment plants, water and wastewater treatment plants, that aims to help compliance and operations for the treatment plant. And then we have a surveillance product, which is meant for public health tracking. I'm going to stop there for a second and see if there are any questions.
Yep, so we'll take one or two questions, and you got 30 seconds to respond. Go ahead. Any perspectives? We see how this fits into our sector for sure, right? Any thoughts? Go ahead.
I'll shoot it out there with AI. You mentioned that. Obviously, everyone's curious about AI. I'm curious to know how many people are using ChatGPT out there. Show of hands. If you're not, you're behind already. I'm telling you that right now. But I don't think it's to be afraid of. Using AI, what is that looking at? It's looking at your data that you've collected, pretty much anything you've given it, and what's the process how do you approach a project to use AI for, say, treatment plant purposes?
Yeah, absolutely, yeah. So a couple of things that come to mind. One of the biggest problems we have is we have a lot of data, but no way to easily validate the data to make sure we get good data. I say garbage in, garbage out. So we want to make sure, so data validation, anomaly detection is one way we use AI to detect sensor anomalies, for example, in a treatment plant or in a collection system. How do you know there is a blockage without having to watch the data all the time? We use AI to detect blockages so that you get alerted about blockages before it's been a month, before a dry weather overflow occurs, and they're like, oh, why did that occur? Then you figure out there's a blockage. So we deliver insights through AI to detect blockages. We can also use AI to be able to model a system. So think about forecasting, right? We use weather forecast all the time to plan our day. Why can't we use weather forecast to predict whether an overflow is going to occur or not? And AI can be used to predict in the future. So a lot of different ways we can use AI, and kind of the power of it is you want engineers to be able to inform how to use AI, because we can use AI in many forms. A data scientist come and say, oh, I'll use AI to do this, but unless it delivers practical solutions and applications to the utility, it's not going to be used. And that's kind of what we pride ourselves. I myself as a wastewater process engineer, so using engineering knowledge to deliver the right information using AI is very critical.
Thank you. And you will be around as well.
Yeah, so we'll be at the Innovation Pavilion all day. Please come and check us out. We can demo our software. It's always good to see and feel rather than just be talked to. So please come by. Yeah.
Appreciate it so much. All right, we got water analytics. Come on up, introduce yourself. Tell us what you're working with.
Wonderful. My name is Ryan Flood. I'm with Aquametrics by Water Analytics. So we were founded by a sensor company, and we have a storied history with our pH sensor. And what we're here at the Innovation Pavilion with today is, being able to show our new smart water solutions. And it's our preliminary design with it, and really the concept behind this is to get the water quality monitoring and data and control into the smaller entities. So a lot of times, a SCADA system is a very high cost prohibitive venture for a lot of these smaller entities, right? Especially in the industrial wastewater applications. They're not able to invest as they would like to be able to get that. But as we've been talking about it, and everyone knows here, right, water quality is so important to the day-to-day use with that water. So what we've brought together is our smart sensors and introducing our new AM2400 controller, which takes a lot of the principles in consumer life, right, at our fingertips, able to connect to it, able to be remote, and bringing that all into a small, simple, easy to use, and affordable package. And that's where we believe we can help a lot of these smaller entities be able to access their data, but also be able to provide the control that they need in their facilities. So it reduces some of their manpower hours. Again, as you guys have talked about, some of the challenges with the resources, a lot of times in industrial applications, there aren't water experts anymore. There aren't the people that they can shift resources to help with that. So they need to be able to monitor that and control it in a very effective way. And that's what we want to try to help them to be able to do, but without having them to break the bank or be able to skip on some of the water quality, especially when it applies to industrial wastewater, as well then eventually move over into the municipal side as it affects that. So with our solution, it's really to bring all this together in a very simple, nice, clean design that any user would be able to implement. They'll be able to access it locally, they're able to access it remotely, and it will be user configurable from that very simple standpoint for what their needs are. So to deal with security, right, some people only want to be able to access their control, their data on site. They don't want it going anywhere. Some people want it just within the facility. Some people want it everywhere. And so that's what we want to try to play with what those balances are. But again, in just one simple platform that allows them to facilitate that.
So I heard three things that stood out to me: simple, control, and affordable. Yes. Is that something that resonates?
No, I really get worried about small facilities getting left behind. We need affordable solutions for them.
Absolutely.
Yes. Thank you. And Ryan, you'll be around a little bit later as well?
Yes.
And you're exhibiting as well?
Yeah, we have a booth at 190 and then also an Innovation Pavilion.
All right. Thank you very much. We want to make sure we have time for Water Hero Inc.
Great. Thank you, first of all, Chi, Michael, for including us in the Innovation Pavilion. I'm here with my colleague, William Thomas, and the Water Hero story. So I'm a recovering burst pipe victim at a pipe break, did $100,000 of damage to my house around 2013. And after cleaning up the mess, I said, there's got to be technology to avoid this. And I had just finished installing Wi-Fi thermostats in the house. And I was pointing to some old legacy solutions, but I said, no, I want something for my water. Like, I want to build a nest for controlling the water. Nothing existed, so being an entrepreneur, I decided to build my own. So I went to Greentown Labs. We won one of their clean web competitions. And so bottom line, we start on residential. Motherhood is, necessity is the motherhood of invention. But we've come full circle that from our residential product 10 years ago, we're now doing 8-inch products. We're at 150 Seaport with an 8-inch main from the city of Boston coming into a high-rise building. What we've also gotten real good at is, our number one goal was to do leak detection for burst pipes. But we realized 60% of our customers find these non-damaging leaks, things like eroded toilet flappers. But the game changers, we provide minute by minute data or even an hourly bar graph. So yours truly, when I first put the device in my house, I could look at my bar graph and said, wait a second, my water never shuts off in my house. 1 a.m., 2 a.m., people are sleeping. Turned out one eroded toilet flapper. I'm up in Beverly, Mass., so it's probably cost me $500 a year, and it could have been doing it for years. But I think the game changer is having real-time water data in your hands. But what we found even bigger, though, is underground leaks. Our biggest one today has been Talladega Speedway. They call us up with a problem. So we like hearing your problems, and we like to come up with solutions. But they were losing 6 million gallons a month, 6 million gallons a month underground. They have a 3,000-acre property with pipes in the 50s. And so we came up with a solution to that for them to help them avoid that loss. But I've heard from some local municipalities, they're losing 40% of the water before it gets to the home, what I call the cash registers with the city meter. So we've recently started in ultrasonic devices. We mainly developed those. We're actually working on a 90-story building now in downtown Toronto that'll probably have thousands of our devices. So it's come full circle. We'll be in the mechanical room with a big 8-inch unit. We'll be on fire suppression with ultrasonic systems. We'll be in every condo suite for both hot and cold water up there. So I think this ultrasonic is something we can really measure flow of liquids in any size pipe. I mean, we could do the Alaskan pipeline if we wanted, but that's what I think might be of most interest to this group, to be able to work with any size pipe. And then the last thing, I've always thought it'd be interesting how you could almost triangulate if there were like flow devices in every home in your municipality, and you audit that against, like, let's say the 5 laterals providing water, we could probably figure out that, hey, things aren't adding up. The household usage is this. This lateral says you're using 10x that. There's probably a leak somewhere. So I'm probably the guy between this whole group and lunch, so I'll cut it short. But anyways, great panel, too. And I mean, just the last thing I want to say, I think the challenge for everyone is people take clean water so for granted, but there are so many moving parts to this, and like the work the people at this conference do is like so under-acknowledged, but so critically important. So thank you.
Thank you. So we understand aging infrastructure and all the problems that we have. There's so many mysteries underground. and that's definitely a problem solver. Yeah. It's like, what are some of these mysteries that's going on underground that we don't see? So we thank you for that. I won't hold everyone up from lunch. Can we get a round of applause for our innovators? And I also want to thank all of our panelists, Tom Sgroi, Gretchen, Janine, John, and Brian. When you're green, you grow. When you're ripe, you rot. So let's keep going with the innovation, all right? Appreciate it so much.
Thank you.